This is a module for even and odd functions. Let me write that. Even and odd functions. Even and odd functions. And we're pretty much just going to graph a function every time the student sees one of these problems. And they're going to be asked whether it is even. They select even, odd, or neither. Even, odd, or neither. And actually, we'll probably have to get rid of those two choices. So we might have to change up a little bit how the multiple choice answers, unless you can think of two good choices to put there. So what we're going to do, the wording will be f of x is graphed below. So f of x, maybe I'll do f of x in the color of the graph. So we'll say, yeah, maybe it'll be like this. So f of x is graphed below, is graphed below, is f of x even, odd, or neither. And the graphs that we'll use for f of x, they're all going to be of the form, and this obviously won't be seen to the student, but they're going to be third degree polynomials. They could just be the ones that are even are all going to be shifted, or they're all going to be quadratics that are only shifted along the vertical axis. So let me write it down here. Well, we'll talk about that in a second. It's more important just to understand what this might look like. So the graph might look like this. Might look like this. Now, let me do a little bit better. Actually, they don't have to be. We could just show that they're symmetric. And if you think of a better way to generate symmetric functions without having to be polynomials, feel free to do so. That would be even cooler. But let's say the graph looks like this. It's a parabola. I'm having trouble drawing parabolas right now. So let's say it looks like that. And let's say it looks like that. So it's supposed to be symmetric. So in this situation, we'll say, OK, let's say they click hint the first time. So you say, we'll pick an arbitrary a right here. Let's say we'll pick that point right there. We'll say that is a. And then we'll do, so the first hint we'll do a. And then it'll say that point right there is f of a. F of a. Right there. Actually, even better would be if we show that that is f of a. That is f of a right there. That's the first hint. Student still doesn't know whether this is an even or an odd function. Show them where negative a is. So if that is a, negative a is going to be right there. That is negative a, and then show them f of negative a. So then go up here, graph that, and then we show that this is, so this is also f of negative a. And we could maybe make that one disappear. We could leave them both places so that this is both f of a and f of negative a. If the student still doesn't know how to do it, we can write maybe on the side here, because we have some real estate, we can write that f of a is equal to f of negative a. So the function is even. That would be for this case, or anything that's symmetric around the y-intercept. Actually, maybe we should make that a hint. Another way to think about it, maybe we'll just write, you can see that it is symmetric. Symmetric, there's two m's in symmetric? I think so. Symmetric, maybe there's only one m. Symmetric around the y-axis, around the vertical axis. So that would be the case for an even function. For an odd function, so we would do something like this. So for an odd function, let me draw an odd function there. Oh, well, all of these, let me clear all of this. I can do my odd function. So clear those out of the way. If the function, an odd function, might look like this. And actually all of the odd functions are going to be just scaled versions of something to the third power. So, or if you want to do other odd functions, generate them randomly so they don't even have to be polynomials, feel free to do so. So an odd function could look, a scaled up version of x to the third power. I guess you could do a tangent as well. But if you show that, and the student doesn't know whether that is even or odd, you ask them to click hint. Once again, you show A there, and then you show them what f of A is. F of A, if they still don't know how to do it, then you go to negative A. And you could maybe literally pick 3 and negative 3 as the points for actual implementation, but you want to keep it abstract. So you call it negative A. And then you show where f of negative A is. And then you mark this f of negative A. And then if they still don't know how to do it and they click hint, you write down that f of A is equal to negative f of A. So the function is odd. And then we could say, notice, this will all be in the kind of the answer, this, the last hint. Notice that the graph is, I guess we could say, flipped. The graph looks flipped across the origin. And of course, they're going to have the Khan Academy videos to back up these concepts. We just want to make sure that they know how to do that specific problem. And then, of course, an example of something that is neither. Let me clear all of these. Let me clear this. Example of something that is neither could be, it could be a cubic that has been shifted. So that would be neither even nor odd. It could be a shifted parabola like this. That is neither even nor odd. It could be and obviously our parabolas, obviously something like this would be even. And also we should also do lines. So this would be odd. Maybe we could throw an absolute value function in there. That obviously would be even. We could just throw in a bunch of examples. And we just want an initial implementation. Maybe we can throw other types of even and odd functions as we go. Anyway, hopefully that made some sense. And obviously for the neither example, you show that f of A does not either equal f of negative A, nor does it equal the negative of f of A. Or the negative of f of negative A.